So I is equals to, it is integral of 1 by 1 plus cot of x into dx. So it is not possible to put, because the moment you put, you try to differentiate cot, as I told you, if you try to differentiate cot, you will have to get minus cosecant square. There is no cosecant square here, nowhere. That means when you try to differentiate 1 plus cot, you have to get 1 into dx. That means only dx. That is not at all possible. So directly substituting over here is not at all possible. Then what has to be done? Possibilities are either you can go for rationalization. That is one way of solving it. You can go for rationalization and then solve it. Rationalizing factor will be what? The possibility 1 by 1 plus cot x is there. You can rationalize that one. That is one possibility you're having. So what will be the rationalizing factor for that one? Yes, for 1 plus cot x, the rationalizing factor will just be the opposite, 1 minus cot x. So divide and multiply by 1 minus cot of x. But working with cot x is again very difficult. So it becomes very lengthy. So what we'll try to do is we'll try to avoid that one. Whenever you get tan and cot, the best way is try to work with sine and cos. Work with sine and cos. So how to write this cot x value? Cot x value can be written as cos x by sin x. So we are converting cot in the form of cos and sine and solving it so that we can find out the solution easily. So cot x will become cos of x by sine of x into dx. But now in the denominator, you can take the LCM. So you are having sine of x as the LCM. So if we take sine x as the LCM, sine x into 1 will become sine x. So you have to write it as sine of x plus this cos of x as it is into what? Into dx. Therefore, now if you try to take the reciprocal, this denominator value will come in the numerator. It becomes sine of x divided by sine of x plus cos of x into dx. That is what we are getting. Now the question is, so if you try to differentiate the denominator, it is not possible to get the numerator. But can I make the numerator and denominator as the same? That's the question. So can I make this sin x as sin x plus cos x? Is it possible? If you want to make that as sin x plus cos x, what is the possibility? Add cos x, subtract cos x. This is one possibility. But even if I try to add cos x and sin x, I can group these two values, sin x plus cos x. But again, this cos x will be left independent. But along with cos x, again sin x should be there. I need to multiply and divide by 2. So once I have divided and multiplied by 2, the next step that I am doing is, so when you try to divide and multiply by 2, you'll be getting 2 times of sin x multiplied and divided by 2. Next step what I am doing is I'm adding cos x and subtracting cos x. So cos x minus cos x will try to get. Further what I am doing is I'm writing this 2 sin x as sin x plus sin x, because 2 sin x can be written as sin x plus sin x. The denominator you are having sin x plus cos x, therefore I am grouping that one. First and the third term sin x plus cos x, and remaining term sin x minus cos x will remain as it is. Denominator will remain as it is. So what I'll try to do now is try to group this one. Divide this term by the denominator. Alright. So therefore I'm writing half as it is, integral sin x plus cos x by sin x plus cos x along with dx. But one more term sin x minus cos x is also left out. So I need to apply that integral for the second term also. Half once again is common outside, and you are left out with sin x minus of cos x divided by what? Divided by once again the denominator itself. Sin x plus cos x into dx. But now if you try to observe the first term will directly cancel out. Both numerator and denominator are the same. Therefore, you can write 1 by 2 integral is just 1. 1 times of dx will give you dx itself, plus this integral will be as it is. Integral of sine of x minus cos of x divided by sine x plus cos of x into dx. Now, since you're getting the numerator and denominator, I'll try to put the denominator value as t, sin x plus cos x to be t. But if I try to differentiate, I have to get the numerator value. Differentiation of sine will give you cos x, and differentiation of cos x will give you minus sine x. Into this derivative of x will be dx is equals to what? Is equals to dt. Or cos x plus into minus will be minus sine of x into dx is equals to what? Is equals to dt. But the moment you try to observe this numerator and this value that you have got is not matching. It is just of the opposite sign. Sine is positive here, cos is negative. But here, cos is positive, sine is negative. So the best thing that you can do is you can take minus common outside. So what is the minus sign? Minus sign value, sine. So first I'll write sine. Now this cos is positive. So how to make this as positive? Minus of minus will become positive, cos of x times of dx will be equals to dt. But again, this minus sign is not there in the numerator. So just to remove that one, I have to multiply by minus of 1 on both the sides. So you multiply minus of minus will become plus, and I'll be left out with sin x minus cos x times of dx. On the right hand side, if you multiply by minus 1 times of dt will be minus dt. So now this has become the numerator value. Now you can substitute in the numerator as minus dt. So therefore, I'll be getting I is equals to, it is half times of integral of dx is there, and we know the formula for integral of dx will be x only, plus half as it is integral of, the numerator has now become minus dt, divided by the denominator is t value that you have taken, sin x plus cos x as t, into the dx is nothing but your minus dt. I have already written it. Therefore, because you integrated, you need to add the constant of integration. So half times of x, minus sign you can take outside, plus into minus will be minus half. It is integral of dt by t plus the constant c, or half times of x minus half, integral of dt by t will give us log of t plus the constant c. But if you try to observe t value, what is t here? Sin x plus cos x. Therefore, you can replace t value to be equals to sin x plus cos x. So log of, it is sin of x plus cos of x plus the constant of integration c. So just replacing t value to be sin x plus cos x, you will be getting the final answer. So this will be the required solution. Now, one thing that you have to observe, how will you get an idea that you need to multiply by 2? On what basis you are using this step? Because if you are solving it for the first time and who doesn't know how to do it, most of the students will stop here only. That will be their last step. They cannot move further. Even if they try to do it, they will try to do this way. Sin x, they will try to add cos x, they will try to subtract cos x, divided by sin x plus cos x. So if you try to do this way, what are the consequences you are going to face? I am grouping the first two. Okay, I have done it. Sin x plus cos x divided by sin x plus cos x. Into dx is there. Let me write down into dx. Okay, minus. Now the second one which will be left out is cos x. So it will be cos x divided by sin x plus cos x into dx. So after integrating, you'll be getting x, because integral of dx will be left out because this will be cancelled out. What happens here? Cos x is there, but what has to be done? You have to get sin x. Therefore, further, one more step I'll try to do, add sin x, subtract sin x. What happens over here is, further if you try to simplify this one, I'm just showing you the consequences. Now I'll try to group what value? This sin x plus cos x. I'll try to group this one. So if I group it, I'll be getting the value as what? Once again, sin x plus cos x divided by sin x plus cos x. It will cancel out and you'll be getting x value. Next value will be minus sine, minus of minus plus. You'll be getting the value as sine of x divided by sin x plus cos x into dx. What happens is, this plus x minus x will get cancelled. You'll get back the original integral, I itself. So you'll be if you try to do this way, what happens is you'll be stuck in a loop, and again you have to go back to this add sin x cos x. Throughout your life, you try to do this one, you'll never end up this problem. You'll never get this solution if you try to do this way. Are you getting this one? Because you start it, again end up with the question, again repeat the same process. So you cannot directly add and subtract cos x. Therefore, what is the other possibility? Other possibility is that because there are two terms in the denominator, I am trying to get four terms in the four terms. Out of four terms, two terms are same. Two terms same, and another two terms are having a difference of negative sign. That's all. Denominator is having again the two terms. So what happens? The first two terms will get cancelled. The second two terms are in the form of dx by x. One is the derivative of the other. So whenever you try to get this type of problem, this is the procedure that you need to follow. But if you come over here and stuck off, then you cannot proceed further if you try to adopt this procedure. So you need to practice this one, this type of problems. Getting it? You have to get an idea that you have to multiply and divide by 2. So what is happening over here if I'm multiplying and dividing by 2? The reason why I'm multiplying and dividing by 2 is so that sin x can be written as sin x plus sin x, and instead of three terms as we have done over here, when you try to add cos x and sin x, you're getting three terms here. But I'm converting that into four terms by multiplying by 2 and writing that 2 sin x as sin x plus sin x. So that four terms becomes, then I can make a group of 2 and 2 and try to solve this way. Getting this point? You can try this similar problem. 1 by 1 minus tan x is homework. Same. This is homework for you. Integral of 1 by 1 minus tan x into dx. So follow the same procedure. Let us try to just try to observe. Are you able to get the same procedure? You need to follow the same procedure what you have done in this example.